Hello, in this lesson, we're going to learn about separable first order differential equations. So let's go ahead and then look at what that is. So let's have a differential equation of the form n of y dy over dx equals m of x, okay, which is a first order differential equation. So we see that what any differential equation which can be written in this form is said to be what a separable first order differential equation. Okay, so this differential equation that we have here is a separable first order differential equation. This is because from this differential equation, you can group all the terms with the y variable at one side and also all the terms with the x variable at one side. So that makes it what a separable differential equation, which is what a first order separable differential equation. So from this differential equation that I have here, I can separate all the terms with the y variable and then all the terms with the x variable. So for me to do this, I just have to multiply through by what the x, right? And that'll give me n of y dy equals m of x dx, right? So you see that you have separated the variables, okay, where you have all the terms with y on the left side and then all the terms with x on the right side. So we see that this differential equation is separable. So any differential equation that we can group the terms with the y variables separately and then the terms with the x variables separately is said to be a separable differential equation. In this case, you are dealing with separable first order differential equation because the highest derivative in this differential equation is what? It's a first order differential equation. So let's look at some examples. Let's have the differential equation 2x plus y dy over dx, okay, equals what? 0. Okay, so I have a differential equation like this. Okay, the first thing you have to do here is to check whether what it is what separable, which means you have to check whether you can separate the terms with the x variable at one side and then the terms with the y variable also at another side. Okay, so looking at this, it is separable because what we can group the terms with the x variable at one side and then the terms with the y variable also at another side. Or you can group the variables. Okay, you can group the variables. Okay, so what I'll do is that I would like to put the terms with what the x variable, okay, together and then the terms with what the y variable also together. So to do this, I'm going to multiply through by what the x. Okay, when I do this, that'll be times what dx. Okay, dx. When I do this, I have 2x dx. Okay, plus y dy equals what? 0. So it's that now you have grouped the terms. Okay, this term here has the x variable and this term here has what? The y variable. Okay, so from here you can write this as 2x dx equals minus y dy. Okay, so we've grouped the x term separately and then the y term separately. So comparing this to what you have here, okay, you see that you'll be able to what? Separate the variable. So therefore, we see that this differential equation is what? It's a separable first order differential equation. Okay, let's look at another example. So given a differential equation dy over dx equals 3x squared over 2y. So given this differential equation here, okay, you see this is a first order differential equation. Okay, so let's see if it is separable. If it is separable, then that means you can group the x terms and then you can group the y terms also. So looking at this, after doing cross multiplication, I'll have what? 2y dy equals what? 3x squared dx. So therefore you have the y terms separated, then we have what? The x terms separated. So this is what? Also a separable first order differential equation. Half sine of y over e to the power x, okay, equals x multiplying dy over dx. Okay, so you have to separate these variables here. Okay, so to do this, I'm going to divide both sides by x, or I'll say I'm going to multiply both sides by what? 1 over x. That what? Times 1 over x, then times 1 over x. This will cancel out this. So then I have what? Sine y over x times what? E to the power x equals dy over dx. Okay, this is what you have now. So from here, what I'll do next is I'm going to do cross multiplication. Okay, so I have what? Sine y dx, okay, equals what? X times what? E to the power x dy. Okay, so from here, what I'll do is that I'm going to divide both sides by sine y. Okay, so I divide both sides by sine y. Here was what? By what? Sine of what? Y. So this will cancel out this. So we have the x. Let me write this here. So you have what? The x equals x times what? E to the power x dy all over what? Sine of what? Y. But you see that we still have what? This x terms here. Okay, so we have to get it to this side. So let's look at how we are going to do this. So to do this, I'm going to multiply both sides by 1 over x times what? E to the power what? X. Okay, so that's times what? 1 over x times what? E to the power what? X. When I do this, this will cancel out this, right? So I then have what? The x over x times what? E to the power x equals what? Dy over sine of what? Y. So at the end, what? We have separated the variables. Okay, so on the left hand side, you have the terms with the x variable, and then on the right hand side, you have the term with what? The y variable. So let's take some examples to help us understand this better. So I have my first example here. I have dy over dx equals 6y squared x. Given the initial condition y of 1 to be equal to 1 on 25. So we are going to solve this differential equation using what? The method of separation of what? Variables. I know this is a first order differential equation. So let's look at how you are going to do this. So what we have to do here is to separate the variables. Okay, so you have to group the terms with the y variable on one side and then the terms with the x variable on one side. So let's look at how you are going to do this. So to do this, I'm going to do cross multiplication here. Okay, so this ds will multiply with what I have here. Okay, so I have what? Dy to be equal to 6y squared x dx, right? Let me write this again. 6y squared x dx. Okay, this is what I have now. So you start, we have y squared here. Okay, but I want to group the terms. Okay, where the y variable terms will be on one side and then the x variable terms will also be what? On one side. So I just have to divide by y squared. Divide by y squared. Okay, so this y squared will cancel out this. So then I have what? 1 over y squared dy equals what? 6x 6x dx. Okay, this is what you have now. I can write this as y to the power minus 2 dy equals 6x dx. Okay, so now we want to find a solution to this differential equation. We want to find a solution to this differential equation that I have here. So how are you going to do this? To find a solution to this differential equation, you have to get rid of what? The derivatives here. Okay, so to do this, you are going to what? Take the integral of what? Both sides. That will be the integral of what? Y to the power minus 2 dy because integral of what? 6x dx. When I do this, this will give me what? Y to the power minus 2 plus 1, right? Over what? Minus 2 plus 1. Okay, so for here, let's leave the constant. So that will be equal to what? The integral of what? 6x. Okay, that will be 6x squared over 2. Okay, then I'll now bring the constant plus c. So this will give me y to the power minus 1 over what? Minus 1, right? So this is the same as minus y to the power what? Minus 1. This will be equal to 3x squared plus c. Okay, so I can write this as minus 1 over y equals 3x squared plus c. Okay, so this will be the general solution. Okay, so this is the general solution. But from the question, we were given the initial condition y of 1 to be equal to what? 1 over 25. So we can use this condition to get the value of what? C, and then that will help us get a particular solution for this differential equation. So let's look at that. Okay, so now I have the solution to be minus 1 over y equals 3x squared plus c. Okay, given the initial condition y of 1 equals 1 over 25. So I'm going to what? Use this initial condition here to find the value of what? C. Okay, so let's look at that. So that will be minus 1 divided by what? 1 on what? 25. Okay, equals 3, 1 to the power 2 plus what? C. Okay, so this is like minus 1 divided by 1 over 25, right? So that will be the same as what? Minus 1 times what? 25. So for the left hand side, we have minus 25. Okay, this will be equal to what? 3 plus what? C. So I take this 3 to the left hand side. Okay, so I have minus 25 minus 3 equals what? C, and that give what? Minus 28 equals what? C. So you therefore have C to be equal to what? Minus 28. So this is the value of what? C. So to get a particular solution for this differential equation, you have to substitute the value of what? C into this general solution that you got here. Okay, so now let's do that. Okay, so the general solution was minus 1 over y equals 3x squared plus c. Okay, so now you know the value of c to what? Minus 28. So that is what? Minus 1 over y equals 3x squared minus c, which is what? Plus c, which is what? Minus what? 28. So this will be the solution, giving what? The initial condition that we have here. Okay, so let's take another example. Okay, so the next example here is we have y prime equals 3x squared plus 4x minus 4 all divided by 2y minus 4. Okay, given the initial condition to be y of 1 to be equal to what? 3. So you have to solve all these differential equations use what? Method of separation of what? Variables. Okay, so let's go how you are going to do this. The first thing I'm going to do here is that I'm going to rewrite this y prime here. Okay, so y prime is the same as what? The y over the x, right? So I therefore have the differential equation to be the y over the x equals 3x squared plus 4x minus 4 divided by 2y minus what? 4. So you have to group the terms, right? The terms with the y variable will be on one side, and then the terms with the x variable also be what? At one side. So doing this, I'll have 2y minus 4 dy equals 3x squared plus 4x minus 4 dx. So you've grouped the variables. Okay, you've done the separation of the variables. So now we want to find a solution to what? This differential equation. Okay, so all you have to do is to get rid of what? The derivatives. And you can do this by what? Integrating both sides. Okay, so I'm going to integrate both sides. When I do this, this will give me 2y squared divided by 2. Okay, then minus what? 4y. This is a constant, so it will assume what? The variable y. So that what? Minus 4y. Then this will be equal to 3x cubed divided by 3. Okay, plus what? 4x squared divided by 2 minus 4x. Okay, so simplifying this, I have what? Y squared minus 4y. This will be equal to what? x cubed plus 2x squared. 2x squared minus what? 4x plus the constant c. Okay, let's not forget it. Okay, so what you have here is the general solution. Okay, so we've been given this initial condition here as what? Y of 1 equals what? 3. So to get a particular solution for this differential equation, we're going to substitute what? The condition given into the general solution to help us get what? A particular solution for this differential equation. So let's do this. So you have what? 3 to the power 2 minus 4 multiplying 3, which is equal to x, which is what? 1 to the power 3 plus 2 multiplying 1 squared minus what? 4 into bracket 1 plus c. So let's simplify this. So 3 squared minus 4 multiplying 3, that'll give me minus 3. Okay, this will be equal to what? 1 plus 2 minus 4 plus what? C. Right? That'll give me minus 3 equals minus 1. Okay, plus what? C. So we want to find C, so that was minus 3 plus 1 equals what? C. So that gives us C to be equal to what? Minus 2. So to get the particular solution, you have to substitute what? This minus 2 in place of what? C here. Let's look at that. So we now have the particular solution to what? Y to the power 2 minus 4y equals x cubed plus 2x squared minus 4x minus 2. So this will be a solution given the initial condition that we're given. Okay, so let's take another example. So the question I have here is y prime equals e to the power minus y multiplying 2x minus 4. Given the initial condition y of 5 equals 0. Okay, so let's look at how I'm going to do this. So the first thing you have to do is to separate the variables, right? So let's not forget that y prime is the sum of what? The y over what? The x. So substituting that, we have what? The y over the x to be equal to e to the power minus y multiplying 2x minus 4. Okay, so this is what you have now. So from here, I'm going to multiply through by what? The x. Okay, so that gives me the y equals e to the power minus y 2x minus 4 dx. Then I want to separate the variables, so I have to divide by e to the power minus y. Divide by e to the power minus y. So this will cancel out this. So then I have what? 1 over e to the power minus y dy. Okay, equals what? 2x minus 4 dx. Okay, this is what you have now. Okay, so what I have here, okay, I can write this as e to the power y. Okay, this is what? E to the power y dy to be equal to what? 2x minus 4 dx. Okay, so now we have separated the variables. So what we have to do is to integrate in order to get rid of what? The derivative. Then that will give us what? Our general solution. So you have what? E to the power y dy, okay, equals 2x minus 4 dx. So we are going to integrate both sides. Okay, the integral of e to the power y give me e to the power y. And at this point, we are not going to bring the constant. So let's leave it this way. The integral of what? 2x will be 2x squared divided by 2. And then the integral of what? 4 will be what? 4x. Okay, then you bring the constant. So this will give us what? E to the power y equals x squared minus what? 4x 4x plus what? C. So what you have here is the general solution. Okay, so we have to find a particular solution by applying what? The initial condition that we were given here. Okay, so let's do that. So all you have to do now is to use the initial condition to get what? A particular solution. Okay, so you have e to the power y equals x squared minus 4x plus c. Okay, so given the condition y of 5 equals 0, you have what? E to the power 0 equals 5 to the power 2 minus 4 multiplying 5 plus what? C. Any number to the power 0 is 1, so we have 1 here to equal to 25 minus 4 times 5, which is what? 20 plus C. So I have 1 to equal to what? 5 plus C. So taking 5 to the left hand side, we have what? 1 minus 5 to equal to what? C. And then you have what? C to equal to what? Minus 4. So what you have to do is to substitute this minus 4 in place of what? The C that we have in the general solution. So we therefore have e to the power y to equal to x squared minus 4x minus 4. This will be the solution given the initial condition y of 5 equals what? 0. That's all for this lesson. Thank you very much for watching.